This video will introduce you to the concept of what LeChat does and the idea of shifts. So, first of all, like a naughty teenager, whatever we do, what we do is the outside stress, okay, right here. Come on, let's get this. All right. Outside stresses, that's us. That's what we're doing outside the chamber. He will try to put it back the way it was. So have you ever noticed teenagers usually want to do the opposite of what you ask them to do? Well, LeChat in that respect is like a naughty teenager. Now what we're going to do is have you copy this down, stop the recording, and copy down this screen. Next, I'd like you to get this down little bit by little bit, and we're going to talk about concentration first as a stressor. Remember, stressors are from outside. They do not have anything to do with the solution itself other than we're adding or subtracting things, or changing the conditions like the temperature, or we're changing the pressure. And those are the three stressors that we're going to be talking about. But today we're just going to deal with concentration, which has to do with the number of species, and volume, which has to do with smaller or larger volumes. So stop the recording and copy down everything that you see right now, and understand that we're going to go down to about this point as we copy this stuff down. So leave yourself room on the paper and do this on an entire sheet of paper. Give yourself lots of space, so this will make sense to you when you read it later. So stop the recording, copy down what I've got right now. Let's just start with this much, okay? So copy down the thing on concentration of species and the headings. Now let's go across and see what this is all about. Do you see, if I increase the concentration, which I'll use an up arrow to demonstrate, LeChat is going to want to decrease the concentration, which I have in a different color, and it's also a different size, which indicates to you the relative thing that's going on. So with LeChat, if we increase concentration, he wants to decrease it. Now, what he does is he decreases the number of species. That's what he can do. And he can do that using the balanced chemical equation. So we want to get that down, and then how he actually does it is he's going to shift to the opposite side from the species that represents the stressor. Okay? So that's what we're doing here in our first example. Now let's go over to the next page and get out your little chart like this. So on a different sheet of paper than your little chart that you're looking at right now, which you have a copy of, and was that today's handout. And to get this handout, you can go to the homework for today, which is April 29, 2014. And there is a link there that will get you this particular sheet, which I used as a handout today in class. So copy down that equation and stop the recording to do that. So first example, what I chose to do was from the outside, I put in I made a higher concentration of carbon monoxide, and I did that by adding it to the gaseous vessel where I originally mixed carbon monoxide and Cl2, which are going to in turn produce carbon, oxygen, Cl2. COCl2, you could say. I'm not sure how you would name that, but we'll just use it COCl2. So, at some point in time, this reaction will not go all the way, and because of that, it will reach an equilibrium point. And the equilibrium point will either be more this direction, which is going to give us less reactants and more products. I'm sorry, less reactants, yes. And then if we move it over this way, we'll have more products. So somewhere in the middle, and I'll just put this in the middle, is where we're sitting right now. So by increasing the amount of CO, I have just probably going to be increasing the amount of my COCl2. So it's going to shift this guy a little bit to the right, but we'll see that in just a minute. So what is actually going on down here is this stuff is increasing. This stuff, LeChat is going to try to decrease. So we're increasing, LeChat wants to decrease. How does he do it? He has to remove it. Now, all he can do to remove it is either make it a decomposition reaction or more of a decomposition reaction where I'm shifting to the left, or make it more of a synthesis reaction, in which case I'm shifting more to the right. And either way, the stuff is going to change. In this particular case, since I want to remove this stuff, I have to put this together with this to make this. So in that last screen, before we did anything, we actually added 6 of each of these, and let's just put them in. Actually, let's make 8 of each. 1, 2, 3, 4, 5, 6, 7, 8. And then let's put in 8 of these guys, because we need them in equal amounts, don't we? Because it's a 1-to-1 ratio according to the balanced equation. So here we go, we're putting in our chlorines, and what's going to happen? What's going to happen is this reaction is going to occur. We've got all our stuff in now, so let's go ahead and what I call equilibrate, and now some of these guys are going to come together and form this stuff, okay? And let's just imagine, I'm purely hypothetical here. I have no idea what this would actually do, but let's say that this is the final state of things. And whoops, here, let's get this back down. And now let's just go down here and get these guys, bring them back up. So now we are at equilibrium. See, I just opened that up. So being now at equilibrium, we can do what we did over here. We add the carbon monoxide. So when we add the carbon monoxide, let's put a couple of more of these guys in. We're asking, what does LeChat want to do? Well, we know LeChat wants to remove some of these guys because he doesn't like those guys being in. He was at equilibrium and everything was hunky-dory. Well, what does he want to do? He's going to put some of these guys together so that he can form more of the product, and he hasn't used up everything that I added. Okay, so we're going to be sitting here with a new equilibrium where we have 1, 2, 3, 4 of these guys, and we've also reduced the amount of carbon monoxide. You see, he can't put it back the way it was, but he can take some apart. And so let's say he takes this guy apart and this guy apart. Now you see, we were not at equilibrium, but now we're back to equilibrium again, but it's a new equilibrium. So I just corrected the numbers over here, and I made them 8 and 8, which is where we added at the original point. And here's what we have right now, a whole new equilibrium. So LeChat did his thing, and we did our thing. We added the things. We became these stressors when we added a couple of more over here, and that made us not at equilibrium. And then when LeChat did his thing, he brought us back to a whole new equilibrium. It wasn't what we started with, but it is good. And LeChat has done as much as he can do. And how did he do that? He removed the carbon monoxide, but notice when he did that, he not only removed carbon monoxide, there we go, he not only removed carbon monoxide, but he also removed a chlorine. And in the process here that we went backwards with, the chlorine went back over here, and I brought back a carbon monoxide, which reduced the numbers of the carbon oxygen Cl2, the COCl2, and it increased both the carbon monoxides as well as the chlorines. You can run this tape back, or this video back, and you can watch that process again. But right now, he did his thing, he removed it, and the way he removed it was by making this reaction shift to the left. So we got ourselves a left-hand shift. And that's what it's all about. So over here, we're going to go ahead and put in the shift is going to be to the left. That way, we are able to remove some of this guy. And so when we remove some of this guy, we wound up making this guy and this guy, which is what you saw over here on this screen. All right, let's try it again. Let's do a different deal where we decrease the amount of COCl2. And so we know that if that concentration is raised, the concentration needs to go down, or up, that is, according to LeChat, COCl2. So let's make up a case for this particular situation. Let's say we're back to this situation, okay, where we have some, let's get rid of this guy. We didn't have him originally, so let's go ahead and delete him. And let's just have our original amount, and let's equilibrate, and then we'll go ahead and figure out what we need to do. So well, here we are. Let's get this arrow out of the way and see if we're going to go the same way or a different way. And we might have to make a different arrow if we do. So let's go ahead and put a few more of these guys together. Okay, let's put them over here together. Okay, now we have, let's call this equilibrium. So we're at equilibrium. Now, in this new stress, what we did is we reduced the amount of COCl3. Let's go ahead and take one of these guys apart, which will mean that we are now not at equilibrium. Okay, but we did this from outside. Now, LeChat has seen what we've done, and what he wants to do is he wants to increase the amount of COCl2. And perhaps we should go ahead and stress it even a little bit more, and we are definitely not at equilibrium now. Okay, so let's go ahead and equilibrate. Well, the new equilibrium point will be at a different place, and we don't really have anywhere to go. So I guess I should have set this over here. Oops, just a second. So let's make this the new equilibrium point. Okay, if that's the equilibrium point that we have now, let's go ahead and take, oh, we got to get more because we're going to take some out. There we go. So now we are, say, at a new equilibrium. So this will be our equilibrium point. And that's where we are before we started example 2. Okay, we took some out. That was the stress. So let's take some out. Okay, we're going to take one out. And now the thing is no longer at equilibrium. And because it's no longer at equilibrium, and let's really stress it. Okay, we're going to take 2 of them out. And LeChat is going to try to reestablish a new equilibrium. He can only go so far because all he can do is work with the balanced equation, which means what he did was he just made what? A right or a left shift? Well, he actually made a left shift. So because we made more of this product, remember I added this, which was made from this and this, we wound up having a right-hand shift because we removed some of this, but LeChat then wanted to make more. And so what we wound up with, for him to add more, add COCl2, he had to do a right-hand shift. Shift to the right. Okay? I think the little example back there on the other screen, this thing here, whoops, we got to equilibrium. Let's move it to equilibrium. We're now at a new equilibrium. And that new equilibrium represents what you see here. And we got there by doing the right-hand shift, which put together CO, and, well, this CO and this Cl2 to make this product. And that was our right-hand shift. Now in this shift, we have a situation where we're reducing the Cl2. So let's take us from equilibrium, which we're going to establish on the next page in just a minute. And what we need to do in the meantime is say what LeChat wants to do, which is increase the Cl2. And now, for him to increase the concentration of Cl2, he has to add Cl2. Well, let's look. Okay, first of all, we're going to establish a new equilibrium. This is before we ever started that line on the last page. Okay, this is the equilibrium that we want. And now that's back together. Good. So let's get this arrow out of the way because we don't know what's going to happen yet. We're going to figure that out. So we have just, we're going to take away Cl2. This is our equilibrium. We're at equilibrium. And I'm going to take out the Cl2. And so let's go ahead and remove some Cl2. Oh, let's get rid of a couple of them. Okay? Let's go ahead and delete these. And now, LeChat is enraged. And so he wants to bring those guys back, but he can only bring back a little bit. He can't go all the way. So, what does he have to do? He has to take this guy right here and break him apart. Okay, we're going to break him apart. And now we're going to establish, and let's get that back together. And here, there, okay. And now we've got a new equilibrium. We are at equilibrium now. When we were back over, whoops. When we were back over here, and these guys were together, that was at equilibrium. When we did this and took them apart, we went ahead and reestablished a new equilibrium, different than what we had before. And so what did we do? We had a left-hand shift. The left-hand shift because we were taking stuff off of this side. Remember, we had a COCl2 here, and we took them apart to make more Cl2. And that is why we had a left-hand shift. I think the models help a lot. So I hope that that's helping you now to understand how to deal with pressure. Or not pressure, I'm sorry, concentration. Concentration of the molecules. All right, let's see the next thing that we want to deal with. Okay, we saw all of this. Actually, I don't think I had you write this down, so you want to do this. Obviously, it's just the opposite of what we did on the first line here. So stop the recording and go ahead and copy that down. Okay, thank you for getting that all done. And now let's go down and let's look at something new. This is what we're going to deal with next. Volume. When we change as a stressor, when we change the size of a vessel, we're going to change the pressure. And so we're going to treat this as a pressure change. But when the volume gets smaller or larger, the pressure will also get smaller or larger. So if we want to get more pressure, we have to get the volume to go down, and when we want less pressure, we have to make the volume get bigger. So less pressure, and this actually doesn't work, so let's get this out of the way. So smaller or larger? More pressure with less volume, less pressure with more volume. So what we're going to do in this scenario is we're going to look at this line. So go ahead and copy this down, and you want to turn off the recording and do that, and then we'll continue. Okay, now that you have that down, let's go ahead and fill in the column that says what LeChat wants. And okay, so with the pressure going up, what Le Chatelier has to do to reduce the pressure is to reduce the number of moles. When he reduces the number of moles, he has to go to the side of the equation that has fewer moles. So if the equation has the same number of moles on both sides, he can't do anything. His hands are tied. But if they are different, he can make some adjustment. So let's see what I'm talking about with that. Let's go ahead with, again, the same equation, only this time we're going to do a volume up. When the volume goes up, the pressure goes down. And so we're going to put the pressure down because we put the volume up. Now, LeChat can't do anything about the volume. Remember, all he can do is either move the equation this way in the side towards synthesis, or move it this direction and move it towards decomposition. So, how is he going to get the pressure to go up? To get the pressure up, what he does is he goes to the side with more moles. Well, let's add up the moles on the left side. For getting the moles, we have to look at the coefficients. Now, coefficients on all these guys are 1. So let's add up the coefficients on the left side. We have 1 on the CO. Boy, take that thing to move. There we go. Okay, we have 1 on the CO. Okay, there's no number there, so we call that a 1. There's no number here, so we call that a 1. And the total of the coefficients on this side, which is giving us the relative number of moles, is going to be 2. And the total of the moles on this side would be 1. So 2 moles versus 1 mole. So if we want more pressure, or if LeChat wants more pressure, he has to shift to the left, which will make a 2 for 1 for each one of these guys that he takes apart. So if he takes one of these apart, he's going to get 2 back. And all atoms or molecules of gases take up the same amount of space, which produce the same amount of pressure. That's why this works. And re-listen to that 5 or 10 times until it sinks into your head, because that's a tough one to understand. So, in this particular case, what is he going to do? Is he going to decompose and make more CO and Cl2, or is he going to synthesize and make more CoCl2? Well, if he goes this way, he's going to get more moles, and that will give him more pressure. So we have to put in here that he's going to make more moles, and the more moles have to be of the stress, are going to be a way to reduce the stress. It doesn't really matter molecule by molecule. It's which side has more moles. So when we look at it this way, the shift has to be to the left. So what happens in our equilibrium reaction is making more moles actually means that these guys have to come apart, and now where these guys are together, they only represent 1 mole. When these guys are apart, they represent 2 moles of gas. And by being 2 moles of gas, they actually increase the pressure. And now, this guy it was not at equilibrium when we started, and he moved it back to a new equilibrium at the end. Okay, let's see, there's only 2 things that you can do here in the pressure type problems. You either increase it or decrease it. To increase the pressure, you've got to get a smaller volume. And let's do that. To go pressure up, the volume has to go down. Okay, less pressure is more volume, and more pressure is less volume. So you might want to add that to your notes as you copy this line. Copy the line while you stop the recording, copy the line, and then come back. So here's a new scenario. We do the opposite that we did last time. Let's make more pressure. And how did we make more pressure? Yes, by decreasing the volume. So if we decrease the volume, how is poor little Le Chatelier going to make less pressure? Well, let's look at this side and let's see. If I do this and I put these 2 guys together and move them over to the left or over to the right here, that means I've got a right shift, don't it? And because I have a right shift, that means that I have gone to the right to do the synthesis type of reaction. And that would make fewer moles, because over here I have 2, and when the reaction occurs and we shift it back this way, we have just made fewer moles, which reduces our volume. So that gets our pressure up. More moles, more pressure. Fewer moles, less pressure. So we want to make fewer moles, and when we make fewer moles with that reaction, the one that you're looking at right up above, to make fewer moles, we are doing a right-hand shift. Which is why you see this arrow now to the right. And we're at equilibrium, and everything is happy and hunky and dory. And that's it. I hope you understand now how to deal with problems where you're dealing with concentration and volume, which is also known as pressure. Thanks for watching.